Hi, my name is Sean. I'm going to be introducing to you some basic statistics and also how to use a software language called R. So you'll not be able to see my face today, and sorry for that because I'm having a bit of technical difficulties with my laptop camera. But today we're going to be doing something a bit more interesting than what we've been covering for the past two lectures, because the past two lectures are more about how we make vectors, what R is, a lot of like basic stuff, whereas now we're going to do a bit more of something called data wrangling, which is a process in which we change data so that we can use it for our advantage. So to do some basic data wrangling, what we always do when we first open RStudio is probably to use the library command to bring anything that I need. So I'm going to load library dslabs and also data murders in order to load this murder data set. So last time we used something called the accessor operator. So if we use the accessor operator, we would firstly want to see what kind of columns are in this dataset called murders. So after I verify the state, abbreviation, region, these are some of the columns that are inside murder dataset. We then begin by using the accessor operator to access the number of states, access the type of states that are inside this dataset. And if we do this, we would basically get the same thing. So this is again a basic recap of the accessor operator, and we call this the accessor operator because it allows us to access these data within a dataset. But now let's say that I want to find the murder rate in each of the states. So note the fact that if I load head of murders, there's only the total number of deaths and the population, which means that I don't have the murder rate of each of the states. So what I do is that I create this new vector called murder rate. So murder rate is basically going to be the number of murders per 100,000 people for each state. And then I'm going to store that inside this variable, this vector called murder rate. So how I'm going to do that? I first, if I do this, only the total number of murders would go into murder rate. But if I divide this by murders population, then multiply it by this number, then what I would get is the murder rate for each of the states. So for column number 1, this is the murder rate. Column number, not column, but row number 1, row number 2, row number 3, row number 4, and so on and so forth. If you think that this is a little bit confusing or difficult, it is going to be much easier as we learn a new command called mutate in the future. So, but before that, I think we have to just bear with this. And then what we can also do is that this is basically when we create a new dataset that we want to get. A useful function that is also oftentimes used in R is the order function. So if I put murder rate inside here, so as it is quite self-explanatory from the name, the order function orders a certain vector in descending order or ascending order. And then because we want to order this from most dangerous to least dangerous, we would add this option here. And you see that here I get all of these numbers. So what do these mean? 9. So if we go to the 9th element within this vector called murder rate, what we see is the greatest value of the murder rates. So these are each of the respective indexes, the indices for each of the values within this vector called murder rate that is ordered in descending order. And as we briefly talked about last time, we can also make logical vectors. And logical vectors are basically when we do something like this. For the ones that are smaller than 1, we get true, whereas for the ones that are greater than 1, we will get false. And we can also store logical vectors in a variable, as we briefly talked about last time. But where does all of this take us? Where does all of this, why have we done all of these things? To combine it with the which function extracts only the ones that are true within a logical vector. It returns the indexes. Then what does this give us? Why have we done all of this? Let's say that now I put this into murder's state. So you remember last time that if I type murder's state and 1, I get the first state, the state of the first row inside the murders dataset. Then if I do something like this, I get the first, second, and the third state names inside this dataset. That is to say, if I extract the indexes of the true inside this logical vector called low, and then I put it into murder's state, then I would get the names of states that have low murder rates. So basically this is using the which function, the logical vectors, to extract names of states with low murder rate. So this is a very useful function because it just basically allows us to extract certain information that we need inside a certain data set. So this is an example of what wrangling is. What we can also do here is that we can use something called the AND function as well. So if you've done some C++ or Python or any sort of coding before, you would probably know what this means, which is basically the AND command, something and something else. Logical commands, I'm not sure what you call them, but I think it is there's some kind of name along that line. But what we want to do, nevertheless, the name doesn't really matter, right? Is we want to get the names of states that are in the northeast region and at the same time have a low murder rate. So let's say that I'm a person who is going to move to the northeast. And then I want to live in a safe neighborhood, so I will probably look for states that have low murder rates. So this is when a logical command, this AND command, becomes quite handy, because I want to know a state that is in the northeast and at the same time has a low murder rate. So in this case, what I do is that I do the same thing that I would do to extract states that are located in the northeast. And you see that this is only possible because we have a column named region inside the murder dataset. So if I do this, what I get in return is is a logical vector where it is returned true if the state has a low murder rate and is also located in the Northeast. So we can use the same method here, where if I use the which command, I get the indexes, and oh, sorry, my bad, I'm not supposed to use normal brackets. Yes, so if we do this, we would get Maine, New Hampshire, Vermont, these three states that have low murder rates and at the same time are located in the Northeast. To do this a little more conveniently, to write a bit more simpler line of code, we can change it to something like this, where we store the indexes inside a separate vector and then get the names of each of these states. So this is an example of how we would use the AND command in order to get some kind of data that we want. But now, let's learn about a new command, which is mutate, which I personally think is a very, very powerful tool. It's called the mutate function. And the reason why it's called the mutate function is precisely because it just allows us to mutate a data set so that we make additional columns to the original data set. So let's first examine what this murders data set looks like. So it basically looks like this. But I want to add a new column to this, which is murder rate. So how do I do that? So I first write mutate and then add on this murders, which is basically, so the first term of the mutate function specifies which dataset that we are going to mutate. And then in the next part, we specify how we are going to mutate it. So first we state murder rate, which is the name of the column, the name of the new column. And unlike most coding languages, a very interesting thing about R is that I can use the exact same name, murder rate, inside this column. So I used murder rate here, but it doesn't mean that the text, like the character murder rate, is defined globally. So I can reuse this as a name of a column. So basically I can also use murder rate as the name of a new column here, and then oh sorry, we have to load the dplyr package. Yes, so you see here that what we've just basically done is that we mutated the dataset so that there is an additional one. And then if I put this into murders, then if I load head murders again, it will look very different. Not very different, but it looks different from what it looked before, which was a dataset without the murder rates column. So basically, this is also a very powerful tool. But another way that we can use the mutate function is something called the pipe command, which I personally believe that is one of the most useful aspects about this R Studio programming language. So to use the pipe command, you also have to load dplyr package, and then how you use this is that before that, I will firstly reset the murders dataset because we want to do this all over again. And if you already have the murders rate package, we can't do it. Okay, Okay, so I first basically reset that, and then I reload library dslabs dataset murders, and then library declare. No, what did I just do? So dplyr dslabs and murders. Okay, perfect. So now we use something called the pipe command, which basically looks like this. So what do we do with a pipe? A pipe is used to transfer objects from one place to another, right? So just like a pipe, so just like a pipe that moves something from one place to another, what the pipe command does is that it also moves some kind of data from one part of the code to another part. So to specify that, to make it a bit more straightforward, it basically looks like this. If I write something like this, it means that I am sending this murders dataset to here, some whatever code that is going to come here. So let's say that I say mutate murder rate total population. So if I write this, I again get something that is same as what I got here. But you can see here that this is a much easier way of doing things, because now it's much clearer. So the code is much easier to read. So there's readability has definitely improved. But also one of the reasons because now you do not have to use the accessor operator. Mutate recognize the pipe command. So the pipe command basically tells mutate that this dataset is the one that's going in. So there's no need to write the accessor operator for each of the variables within the mutate function. So this pipe command can be very useful and a very powerful tool when you're dealing with, especially dealing with mutate functions that will involve lots of complicated calculations. To go a bit more into processing data, we can also talk about the filter package. So the filter package is basically when as the name tells you, you filter specific data. So this is very similar to what we have done up here, which function. So basically, in the filter function, if I write something like this, sorry. Oh, why isn't this working? Oh, I wrote murders rate. That was why it wasn't working. Okay, so here, you see that what I have done is I wrote filter murders, murder rate smaller than 0.7. Another way of doing this is that we can use the pipe command. I personally like using the pipe command because it makes things much readable. So if I write like this, I am putting the murders dataset inside this filter function, and I'm only filtering the rows that have a murder rate smaller than 0.7. So that is why I get only these 5 columns. You see that only these 5 columns have a murder rate that is smaller than 0.7. So this is how we might use the filter package in order to select certain columns to work with. So this is how we filter rows. This is how we select specific rows inside the dataset. But what if we want to select certain columns inside the dataset? That's when we use the select function. So the select function basically works like this. We use the pipe command first of all, and then we apply the select function to just basically select the variable, the columns that we want to work with. If I write like this, I only get these columns. The columns that I've listed inside here. And the reason why I like using the pipe command becomes a little bit more clear here. Because the pipe command allows us to work with multiple functions at a time. So if I write like this, I first select this only these four columns: the state, abbreviation, population, and murder rate, and I plug this data set inside this filter. So you see here that I have filtered only the rows that have a murder rate smaller than 0.7, and at the same time I have also chosen only the columns: state, abbreviation, population, and murder rate. If we try to do this without the pipe command, it will probably result in like lots of nested brackets, so it is considerably easier using this command. Although the plot function has a built-in command for logarithms, we can also apply this to get log 10 values of a certain variable and then directly plot that as well. So that's a very interesting application of how this might happen. The two final functions that I want to introduce are the sum and the mean, which are probably pretty much self-explanatory by the names of the functions. So the sum function is when you sum the number it's basically when you sum all of these. So if I write like this, no, actually that's quite pointless. I should have used mean for this example. So the mean function, when you put this data set into here and press, okay, that was not a good choice. So if you see here, the accessor operator allows us to extract the murder rates within the dataset murder, so you get this, and the mean function computes the mean of each of these variables, which is 2.77 something something something. This can be highly useful when you're dealing with a dataset that probably follows a normal distribution, because normal distributions are described using the mean and the mean and standard deviation of the dataset. So that could be a pretty good application of this. Instead of using the mean, you can also use the sum command. So let's say that I want to know the total population across all of these 51 states. Then I use the sum command in order to do something like this. But I can still use mean in order to compute the average population of each of the states. So in today's lecture, we have covered actually a lot of things. We've covered the basic data wrangling, which is basically changing data, mutating data so that it is more easily usable for us. In particular, we talked about the order function, which function, mutate function, pipe, filter, and select. But I think the most important functions in today's lecture was probably mutate and pipe and filter, in the sense that these allow you to extract or mutate a certain dataset to your own advantage. So thank you for listening, and see you in the other lectures.